In this question, we want to determine the derivative of x squared minus 3 as a quantity to the exponent 2x plus 5. Well, when given a situation where you have x in both the base of the exponent and in the exponent itself, it's wise to determine the natural logarithm of both sides. So we have ln y equals ln entire quantity. And we know that it's a property of logarithms that we can bring that exponent down in front. So we've got 2x plus 5 times the natural logarithm of x squared minus 3. Now we're going to determine the derivative of both sides. Well, we know the derivative of 1 over x, we know the derivative of ln x is 1 over x. So therefore the derivative of ln y is 1 over y dy dx. It's a chain rule. If the derivative of ln x is 1 over x, then the derivative of ln block is 1 over block times the derivative of that block with respect to x. The derivative of ln y is 1 over y times the derivative of y with respect to x. Now we have to determine the derivative here. Well, that's just a product rule. Derivative of the first, which is 2, times the second, ln of x squared minus 3, plus the first, 2x plus 5, times derivative of the second. So the derivative of ln block is 1 over block times the derivative of that block with respect to x. And now it's just a matter of cleaning this up a bit. So we've got 2 ln x squared minus 3 plus 2x times 2x plus 5 over x squared minus 3. Now that's what 1 over y times dy dx equals. dy dx itself would equal y times this expression. In other words, just multiply both sides by y. But remember what y is. Y is x squared minus 3 to the exponent 2x plus 5. So we sub that in for y, and we have an expression for dy dx.